What's up, gang? So today we are going to discuss banana bond. So this is a topic which is rarely discussed properly in class. I have made notes from IIT professors and their notes and JD Lee. So this is going to be a very detailed explanation properly with organic as well as inorganic examples. So banana bond, rarely properly explained. So yeah, it was a bit of a history, let's skip that. C2H6 and B2H6, what do we know about that? C2H6 has 14 electron whereas B2H6 has 12 electron. This is how we already know how ethane looks. This is what ethane looks like. There are 6 sp3 1s bonds and one single sp3 bond. On the other hand, B2H6 has 6 boron hydrogen bond and there are no connecting bond. That's what we used to think. So what does really happens when we did a electron diffraction study? We find out that the boron, it is a planar compound first of all, and see the boron, there are in total of a 6 hydrogen, and these 6 hydrogen lie in a plane like this. On one corner this boron have this hydrogen here, this here, and this here. These two will be shared with the other boron, something like that. You guys can see it properly. The bond angle for the terminal hydrogen and boron in between HBH, where the hydrogen is terminal, is 120 degree, whereas the bridge head hydrogen and the boron bonding angle is 97 degrees. Now this is all theoretical, so no need to remember anything. 119 picometer is the bond length, 131 for this, 4 th and 2 bond 1. How do we know it? Proof is specific heat rotation, because the carbon bond, the single bond spins properly, whereas this is not spinning. But we do not have to know that stuff. Diborane, this is what diborane looks like. If you want to represent it, draw it, you can draw it like this. The terminal hydrogen, let's talk about the terminal hydrogen. There are 4 BH terminal bond of 119 pm, and it is an electron deficient bond, but it is a normal bond. It is a normally deficient, but not like it is a covalently deficient, not banana type stuff. So two center, this is a two center, this is another center, and there are two electron, localized electron. Like this is a BH bond example. One is boron electron and the another is hydrogen electron. There are two center and two electron. It's normal, by the way. And now let's talk about bridgehead hydrogen. There are two bridgehead hydrogen boron bond, 131 picometer and longer. See, this is a longer bond. Normal should be 119 and this is a 131 picometer, which means it is longer in length. What does it mean? It stretches. The electron density decreases. It is stretching. So BHB, very deficient electron bond. Normal itna, but this is this one itna. So banana bond, 3 center 2 electron. This is where it begins. See, basically this is boron's ground state. This is boron excited, 4sp3 hybrid orbital. Now when we draw it, we can notice that the vacant orbital here is being connected with hydrogen and the other boron. You guys can see it. The hydrogen 1 electron and the boron's 1 electron is now been crossed in between one boron, another boron, and a hydrogen like this. Only 2 electron, but it has been shared upon 3 bonds basically. So yeah, vacant sp3, by the way. Now 1 b electron, 1 hydrogen electron, 2c 2e bond, banana bond. This is what it looks like. It looks like a banana, as you can see. Now let's talk about cyclopropane. This is what we think like cyclopropane exists. Angle strain is there, very dangerous angle strain, by the way. This is lots of energy, 28 kilocalories per mole. But in reality, the carbon bond, the p bond, it goes like this and makes a bond basically, and this is what it looks like, cyclopropane. Yeah, that's it. Banana bond for you guys. You guys can read it if you want.